In this video, we're going to continue our work with hypothesis testing for proportions, but now we're going to move into, well, what if I have two populations or two separate proportions? So I'm going to work with this statement right here. It says, is there a difference between the proportion of all Duke students and the proportion of all U.S. adults that would be bothered a great deal by the melting of the northern ice caps? So I have two separate populations here. I've got U.S. adults, and then I've got a sample of Duke students right here. And if I'm going to do a hypothesis test with these two separate proportions, then, well, I'm going to have some conditions that I need to check for my central limit theorem. This time around, though, I do have a slightly different take on it here because I have two separate samples, which means I have two separate sample sizes. So I need to do a couple things to start off. I need to find what is called p-hat, sometimes it's called p-hat pooled. We're going to pool together our two separate proportions here, and we're going to treat it as kind of one big sample when we're looking at this. So p-hat pooled, when I'm looking at it, the formula that I gave in the notes above are x1 plus x2 divided by n1 plus n2, where x1 and n1 are the number of individuals from each sample that meet whatever criteria we're looking at. So in this instance, we're looking at the folks that would be bothered a great deal by the melting of the northern ice cap. So just so that I can keep this straight as we work through this problem, eventually we're going to start to work with both of these two samples. We're going to want to make sure we know which one is which. Maybe we'll call U.S. adults, we'll call that sample 1, and Duke students will call that sample 2. That'll be important here in just a minute. So I'm going to take the total number of U.S. adults that said they would be bothered a great deal, which is 454, and then I'm going to go ahead and add that to, so plus, the total number of Duke students that said they would be bothered a great deal, which is 69, divided by N1 and N2. Remember, N is our sample size, so that would be the sample of U.S. adults, which is 680, so 680, plus the sample size from my Duke students, which is 105. So going ahead and adding my numerator, if I take 454 plus 69, my numerator is 523. My denominator here, 680 plus 105, I end up with 785. And then we can go ahead and divide these out. 523 out of 785. I end up with 0.6662. Let's go down to 4 decimal places just to be extra safe. So this is our p-hat pooled. Usually we'll just abbreviate this as p-hat. So we have our p-hat, which is the first step. Now we can actually go to verifying the success-failure condition. And the thing about this here is that because we have two different samples, U.S. adults and Duke students, I'm going to have to verify the success-failure condition for both of these two samples. So there's actually going to be kind of 4 conditions here. I need to check N1 times p-hat, is that greater than or equal to 10? And N1 times 1 minus p-hat, is that greater than or equal to 10? And then I'll do the same thing with sample 2. Again, I don't really care what these numbers are. I just care that they are, in fact, greater than or equal to 10. So we said up here that U.S. adults, that was going to be our sample 1, our group 1. So our N1 will be 680. So I have 680 times p-hat, our p-hat pooled coming from this guy over here, 0.6662. So let's see, 680 times 0.6662. I need to go ahead and calculate that out, so bear with me. 680 times 0.6662 gives me 453.016. That is certainly greater than or equal to 10. So yes, we've met the first condition. That's the number of expected successes. And then I'll want the number of expected failures. So that would be 680 times 1 minus our p-hat, 0.6662. So going ahead, 680 times, use parentheses here, 1 minus 0.6662. Here I end up with 226.984. That is certainly greater than or equal to 10, so that condition is met as well. So I verified the success failure conditions for my first sample for 680. Now I need to do the exact same thing for sample 2. So I'm going to be checking N2 times p hat. Is that greater than or equal to 10? And N2 times 1 minus p hat. Is that greater than or equal to 10? So N2 in this problem, remember we said our Duke students was group 2, so that means that our sample size is going to be 105. So working with these down here, 105 times p hat, 0.6662. Let's go ahead and work that out. 105 times 0.6662. I end up with 69.951. That is certainly greater than or equal to 10. So yes, that condition is met. And then N2, which is 105 once again, this time times 1 minus p hat, 0.6662. So let's see if I do 105 times 1 minus 0.6662. I end up with 35.049. That is greater than or equal to 10. So yes, we've met all 4 of our conditions here. So we verified the success failure conditions here. I have N1 times p hat greater than or equal to 10, N1 times 1 minus p hat greater than or equal to 10, N2 times p hat greater than or equal to 10, and N2 times 1 minus p hat is greater than or equal to 10. In general, if I ask you to verify a condition, this is the condition that I'm going to check. Because there is one other that I didn't mention up until right now here, and that's that we need independence with groups. This is, again, very difficult for us to verify. We should be looking for independent sampling, and I'll go ahead and make a note. We should be looking for independent sampling. Independent sampling, meaning that individuals in our sample are independent of each other. But this is very difficult for us to do. So what we are going to look for kind of as a proxy, as a substitute for that, is do we have some form of random sampling? It doesn't really matter what it is, what kind of sampling technique I'm using. As long as I have some kind of random sampling, that's going to be good enough for us. Now, in this instance, this problem didn't tell us that we were working with a random sample. We will just go ahead and assume that this is a random sample. This first condition of independence is really something that we should be aware of, but I'm going to be honest with you, it's not a condition that I'm going to ask you to check. It's not something that I'm going to try and trick you on ever. Usually we can go ahead and assume that that condition is met. If I ask you to verify anything, it's going to be these 4 success failure conditions. That's the important step. That's going to be the part that I ask you about on upcoming quizzes and tests.